So in this video, we are going to discuss exercise 8.1, question number 6. So let's read the question. If angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. Okay. So first of all, let's quickly note down what are acute angles. So we know acute angles are angles which are less than 90 degree. Okay, angles which are less than 90 degree are called as acute angles. So note, angle A and angle B are acute angles, okay, such that cos A is equal to cos B. So to represent this given information in a diagrammatic form, let us take a right angle triangle. So this is a right angle triangle, and let this be a right angle triangle. Let this be a right angle which is 90 degree B. So very clearly A and C here, these are going to be acute angles, okay, because the summation of the three angles of a triangle is equal to 180 degree. Out of 180 degree, 90 degree is gone here. So angle A plus angle C is going to be equal to 90 degree. So A and C both are going to be less than 90 degree. So this triangle here is a correct representation of the given information, that angle A and angle B are acute angles. Okay. Now, now the next piece of information is that cos A is equal to cos B. So this is our cos A and okay, A and B are acute angles. Okay. So we have to rectify this. This has to be B and this has to be something else, because B is our acute angle. Let this be equal to Q. Okay, my bad. We need A and B to be acute angles. So these two are our acute angles, and let Q be the 90 degree right angle in our triangle. Now cos A is equal to cos B. So let's write down the definitions of cos A and cos B. So cos of A is equal to the adjacent side. I'm going to quickly write here. Adjacent side, the whole divided by hypotenuse. Okay. And that is equal to, what is the adjacent side? AQ, the whole divided by hypotenuse is AB. And cos of B is also going to be adjacent. Okay, this is adjacent side of angle A. That's very important, of angle A. And this is going to be adjacent side of angle B, the whole divided by same thing, hypotenuse. This is the definition of cosine, which is the trigonometric ratio. Now, what is the adjacent side of B, angle B? That's BQ, the whole divided by hypotenuse is AB. Okay. So thus we have noted down cos A, that is this, and cos B, that is this. Now they are saying cos A is equal to cos B. Okay. Which means if cos A is equal to cos B, let's draw a straight line here. Okay. Okay. Now, given, let's write here like this, given cos A is equal to cos of B. Therefore, what is cos A? AQ by AB. AQ by AB is equal to, what is cos B? It is BQ by AB. Okay. And now, as we can, so if you multiply both the sides of equation by the denominator AB, we are going to get, let me note down that step, multiply both the sides of equation by AB. So AB is some value. We are going to multiply both the sides. And thus, by doing so, so both AB gets cancelled out. So we get AQ as equal to BQ. So the sides AQ is equal to the side BQ. So if you come to this triangle representation, the side AQ is equal to side BQ. So if AQ is equal to BQ, then this is actually an isosceles triangle. This becomes like an isosceles triangle. So isosceles triangles. angles. Okay, and we all know the property of isosceles triangle. If these two sides are equal, then these two angles are also equal. That is the property of the isosceles triangle. So angle A is going to be equal to angle B, and that is exactly what the question asks. Show that angle A is equal to angle B. Since we showed that these two sides are equal, these two angles are also equal. So angle A is equal to angle B, hence proved. So this was our question number 6 for exercise 8.1. Now let's go to the next question, which is question number 7 from the same exercise 8.1. So again, the question is quite familiar. Let's read it out. If cot of theta is equal to 7 by 8, then evaluate this expression, expression number 1, and this expression, expression number 2. So this is cot of theta. Now theta is some angle of a triangle. So let's represent it in the form of a triangle. So I'm going to do that first. Okay. So this is my right angle triangle. Let's zoom in. So this is my right angle 90 degree. Let this angle be equal to theta. Let me use a different color. So let this angle be called as theta. Okay, and let's give names. So this is, let this be A, B, and C. Okay, now what is cot of theta by definition? By definition, cot of theta is nothing but, so cot of theta, it's a derived trigonometric ratio. It's nothing but 1 upon tan of theta. And what is 1 upon tan of theta? That is equal to, okay, opposite side of theta, and here we will going to have adjacent side of theta. Now in this triangle, adjacent side of theta, this is theta, adjacent side of theta is going to be AB, so that is going to be AB, the whole divided by opposite side of theta is going to be BC, so that is going to be BC. However, cot of theta is given to be 7 by 8, so this is equal to 7 by 8. So thus we get the ratio of two sides of our triangle AB and BC as equal to 7 by 8. Now let k be the common factor. Let k be the common factor between these two sides. So therefore AB will be equal to 7k, that will be its length, and BC will be equal to 8k, that will be its length. So let me in fact note it down in this triangle. AB is going to be equal to 7k and BC is going to be equal to 8k. Now our job is to find AC. Once we find AC, we will have the length of all the three sides of a triangle. Once we have length of all the three sides of triangle, we can easily find any trigonometric ratio that they are asking us to evaluate. So let's go and calculate AC, which is very simple to calculate based on the Pythagoras theorem. So I'm going to draw a line here. So let's draw a line here. So using the Pythagoras theorem, let's zoom in. Yes. Okay. So using, oops. Yes. So using Pythagoras, using the Pythagoras theorem, we have AC square as equal to AB square plus BC square, and that is equal to AB is 7k the whole square plus BC is 8k the whole square. Let's come down. That is equal to 149, sorry, not 149, oops, 40. That is equal to 49k square plus this is 64k square, and that is equal to 4 plus 9 is equal to 13, 1 carry, 6 plus 4 is 10, 11. So 113k square. So this is our AC square, and therefore AC will be equal to, taking square root on both the sides, 113, and k square will be equal to just k. So 113 is not a perfect square, so its square root is just going to be under root of 113. So we get AC as equal to under root 113k. So let's make a note of that here. Yes. So AC is now equal to under root of 113k. Now we thus have all the three sides of our triangle. We have the length of all the three sides of our triangle. So we can easily calculate this value and this value. First, let's focus on this value. We will need to copy it down somewhere. So okay, let's let's take this whole thing down. Copy. So paste. So this is here, and we have got this triangle. So let's also take this triangle down so that we can use it while doing the calculations. Copy, and here we have it. Paste. Great. Okay. So now first we are going to start with this expression. This is 1 plus sine theta into 1 minus sine theta, 1 plus cos theta into 1 minus cos theta. Now we all know that this expression is of the form, let me zoom in. This expression is of the form a plus b into a minus b, the whole divided by, okay, this is also a plus b into a minus b. Okay, this is the form of this equation. So we know that this is a common identity. A plus b into a minus b is equal to, it's a square minus b square. Okay, this will be also a square minus b square. Thus I'm going to reduce this identity to a square, which will be 1 square, minus b square, which will be sine theta square, the whole upon, same thing, this is a plus b, a minus b, so a square minus b square. So this is also going to be 1 square minus cos square theta. Okay, and that is in fact going to be 1 minus, so I'm going to write it like this, sine theta the whole square, the whole upon 1 minus cos theta the whole square. So both these expressions, sine square theta or sine theta the whole square, are actually same. There are different ways of representing the same thing. Now our job is to now find sine theta and cos theta from this triangle, So let's quickly do it. Let me draw a line here. Okay, so how are we going to find sine theta? So sine theta is nothing but focus. So this is our angle of focus, theta. So opposite side divided by hypotenuse. So opposite side is 8k divided by hypotenuse is under root of 113k. So this becomes our sine theta. And then we have cos theta. Cos theta is equal to, once again, this is the angle of focus. So adjacent side will be AB divided by hypotenuse. Adjacent divided by hypotenuse. So cos theta will be 7k divided by hypotenuse is again 113 under root of 113k. Now let's substitute these values here. Oops. So that's going to be, yeah, 1 minus, now we are going to have sine theta the whole square. So that's going to be 64k square, the whole divided by 113k square. I've just taken square on both the sides of this equation. Same thing with cos theta. Cos theta square is going to be 49k square and 113k square. So let's substitute that. This is whole divided by 1 minus 49k square whole divided by 113k square. Okay, so we have got these values. Now we have to simplify this fraction. So what's going to happen is 113k square into 1 minus 64k square, the whole divided by 113k square. In fact, let me write it down. 113k square into 1 minus 64k square, the whole divided by 113k square. This is our numerator. This into this minus this, the whole divided by denominator. Okay, so this becomes our numerator, and now the denominator also the same thing. Okay, 113k square into 1 minus 49k square. So let me write it down. 113k square into 1 minus 49k square, the whole divided by 113k square. Okay, so now this is the denominator, this is denominator. We are going to cancel them out. So I'm going to cancel them out right away. So this goes, this goes. What remains is just this value. So let's see what it evaluates to. So that is equal to 113k square minus 64k square, the whole divided by 113k square minus 49k square. That is equal to, let's do the subtraction. 113 minus 64, that is going to be, okay, 13 minus 4 is 9, and 11 minus 7 is equal to 4. That's going to be 49k square, the whole divided by 113 minus, so 13 minus 9 is again equal to 4, and 5, 11 minus 5 is 64. Oh, it is equal to 64k square. Very good. And then once again k square will get cancelled out, k square, and what remains as our final answer is equal to 49 by 64. So 49 by 64 is the answer of this expression. Okay, so again remember, just to recall, we started solving this expression. This expression is of the form a plus b and a minus b. So we found out a simplified version of this expression, which is a square minus b square, and even in the denominator a square minus b square. So that basically is 1 minus sine theta the whole square, 1 minus cos theta the whole square. Now we have this triangle, so we found out the value of sine theta, we found out the value of cos theta, and we substituted here. Then we simplified this numerator, denominator, and finally we came to 49 by 64. So this expression is equal to 49 by 64. I'm going to make a note here. Yes. So this expression is equal to 49 by 64. Now the next thing is they're asking us to find cot square theta. Now cot theta is already given to us 7 by 8. So cot square theta is nothing but the square of this expression. Okay. In fact, cot square theta is equivalent to, let me write it down here, this thing is equal to cot of theta the whole square. Okay, it's just different ways of writing the same expression. Cot theta the whole square is written as cot square theta the whole square, and but cot of theta is given as 7 by 8. So I'm going to substitute that value, and that's going to be whole square, and that is going to be equal to 49 divided by 64, which is exactly equal to what we got here. Thus, this expression, okay, this expression is in fact equal to cot square theta. Okay. So thus, but anyway, that doesn't matter. We knew what was the value of theta, so we just found out the value of sine theta, cos theta, and substituted in this expression. So this is also 49 by 64. This is also 49 by 64, and that's how we have solved this question number 7.